All right, so here's the first of a bunch of videos I'm going to try to make for statistics, for an intro to statistics class. The idea here being that there's lots of information out there that you could probably find, but maybe not so much just geared towards a student who isn't really all that into statistics, right? Like, I'm taking this class. I don't like you. You don't like me. I'm just trying to get what I need to get out of this class so I can pass and never think about this stuff again. I mean, maybe not quite that negative, but sort of that idea. So what I want to do is I want to make a series of videos that just sort of talks about the minimum you need to pass a statistics class. Let me know what I need to know so I can learn it real quick. I don't need a bunch of theoretical stuff behind it. I don't want to be super interested in this stuff. Just tell me what I need to know and I'll move on. So that's what I'm going to try to do here. And I'm going to organize this in 3 different series because there tends to be 3 topics that students really struggle with in an intro to statistics class. The first one is the normal distribution, and that's what this series is about. I'm also going to make another series about confidence intervals and then another series about hypothesis testing. But first things first, this one is all about the normal distribution. And I'm going to have 7 or 8 videos in this series that are supposed to talk you through the normal distribution. So things like the empirical rule, the normal CDF and inverse norm functions on your calculator, the sampling distribution, all that kind of stuff. If that sounds like stuff that you need to know, well, then you're kind of in the right spot here. So what I want to do in this first video is just that little introduction spiel that I already did. And then just kind of getting students to understand the picture that you're going to draw over and over and over again in this class. Because it turns out that the picture, maybe drawing it is the easiest part, but if you don't really understand it, then when things get a little bit more complicated, you're going to be stuck. But if you can just have a little bit of understanding about the picture that we're going to draw in this video, then when things get a little bit more complex, you'll be in good shape and you'll see that's not really all that bad. So in this one, I'm just trying to draw and understand the picture that I need for normal distribution. So I have a prompt. For example, suppose the weight of an offensive tackle is approximately normally distributed with a mean of 270 pounds and a standard deviation of 30 pounds. And then ... here because the question goes on. Maybe it says determine the probability that an offensive lineman selected at random will weigh more than 285 pounds or something like that. But I don't even want to get into the question at this point. All I want to do is understand the picture. So there's 3 pieces of information you need to take from the stem, I guess is what this is often referred as. The first one, the shape. The shape is going to be approximately normal. That's not a coincidence. That's the shape that we are studying in this section, the normal distribution. So in every single problem, the shape is going to be approximately normal. What you need to know is that when the shape is approximately normal, it looks kind of like that. It's hard to draw on a computer, but maybe I'll let it slide. It's this symmetric bell shape. Symmetric meaning it's kind of a mirror image to the left of where the cursor is versus to the right. And bell shape, it kind of like, I don't know, old school Liberty Bell kind of thing. This sort of kind of looks like a bell here. Maybe you can imagine it, maybe you can't. Anyways, you can draw this shape repeatedly. Every single time it says your shape is approximately normal, or maybe just normally distributed or something like that, you draw this shape. It has to always give you 2 more pieces of information, the mean and the standard deviation. The mean will always be the population mean, which it's good for you to know is this symbol, mu. It's a Greek letter. Maybe not essential at this point, but eventually you'll want to recognize that symbol, so I'm going to start writing it so that later on when you need it, you know it. Mean, mu. Population mean is 270. Standard deviation, so the population standard deviation, that's this Greek letter, sigma. Mu and sigma are mean and standard deviation respectively. And all you need to know about the picture after you draw this thing is you're always going to put the mean in the middle. So in the middle, like right, I don't know, here is the middle. I'm going to write 270. That's the only place the mean is going to show up in my picture, is right in the middle, always. Standard deviation is what I'm going to count up and down by. So if I start at, if I start at 270 in the middle, didn't mean to scroll down somehow, and add 30 to that number, 270 plus 30 more is 300. So I'll put 300 over here. 300 plus 30 more is 330. So I'll put that over here. 330 plus 30 more is 360. So I'll put that over here. You're like, when are you going to stop? I'm going to do that 3 times. Start with 270, count up by 30 3 times. 300, 330, 360. Count down by 30 3 times. 240, 210, 180. If you just kind of space them out so they look something like that, no one's ever going to know that you don't really know where they go, and you're always going to get full credit on it. It's totally fine. Technically, 1 standard deviation above the mean, which is this 300, right? The mean was 270, 1 above it was 300. and one below, this 240, should fall at what are called inflection points. So think about it like you're skiing down this is a hill. The hill's getting steeper and steeper and steeper and steeper, and then somewhere in here, it stops getting steeper and it starts getting less steep. That's what's called the inflection point. That's where one standard deviation above the mean and one standard deviation below the mean will go. But no one is really ever going to check that. So it's not, if you're just trying to pass the class, maybe you don't even worry about all that. Throw 270 in the middle, count up and down by 30s. By the time you're 3 30s above 270, be pretty close to the end here. By the time you're 3 30s below the mean, pretty close to the end here, and you're good. Technically, this thing goes on infinitely long in both directions, but you gotta stop drawing it at some point. So when this gets close to this axis, you stop drawing it. Put this close to the end. That's all you need to know. That's it. Do that over and over again in this section. It'd be awesome. Suppose the volume of a dog's loudest bark, okay, these examples get kind of dumb, is approximately normally distributed. There's that key word. It means I'm going to draw something that's symmetric bell shape. I'll try my best on the computer anyways. Better tell me a mean and a standard deviation. Oh, there it is. There's the mean. If you're showing off, you might know that that's mu. And there's the standard deviation. That's sigma. I always put the mean in the middle and count up and down by the standard deviation. So in this case, it's 80 that goes in the middle, and I'm going to count up and down by tens. There's 3 of them above. Here's 3 of them below. Done. There's 2 things I want you to get out of this video. Why does that keep happening? First one is I want you to be able to draw the picture. And then I guess I did say I want you to kind of understand the picture. And this isn't so that I can be a teacher and get this theoretical understanding out of you. It's because you're going to need to understand the picture for the stuff that gets more challenging later on. So I want to introduce it a little bit now. So for now, we're just drawing these pictures. But suppose later on, you did something slightly different. Suppose later on, you added, I don't know, maybe 280 right here. And you added another number, let's say 320. So where that'd be like right here. And you shaded in the area in between the 2 of those. So there's nothing in this problem that suggests that you should do that. I'm just making up an example. Later on in future videos, you'll learn how to do this. But in this video, I want you to understand, if you got to this point, what would this mean? This 280, this 320, and this shaded area, maybe this is labeled. Maybe you're told that this is 32%. If your picture was not only the blue, which is what you're learning in this, but also had the red in there, I want you to understand what that means. And there's 2 different interpretations of what that means. I'm going to write those out. And if you can get those 2, we can be done with this video. The first one is, if I randomly select an offensive tackle, OT because I'm lazy, there is a 32% chance that they weigh. So that's what we're talking about here. Between 280 and 320 pounds. The first interpretation is, this tells you the probability, if you grab one of these things, offensive tackles in this case at random, the probability that they'll weigh between 280 and 320 pounds. So if I drew another picture, I don't know, down here, and let's throw 95 in this picture, and let's shade over to the right. And you don't know why you're doing the 95. You'll learn that in another video. But suppose that that's labeled as 7%. I suppose that's given to you. I want you to understand that one way you can interpret this is, if I grab one dog at random, there is a 7% chance that it barks louder than 95 decibels. Right, kind of rewriting this sentence right here, except in terms of dogs and barks instead of offensive tackles and their weight. One interpretation is, you grab one at random, what's the probability that they're in that range? The other interpretation is, this tells me the percentage of all offensive tackles that weigh between 280 and 320 pounds. Of all offensive tackles weigh between 280 and 320 pounds. So I guess 2 main things I want you to get out of these is, 1, be able to draw the picture. Fairly easy. It always is symmetric bell shape. Mean in the middle, count up and down by the standard deviations. The other thing is if this is shaded in, if a region is shaded and its area is indicated up here, I want you to know what that means. And unfortunately, it can mean two different things. Either it tells you the probability if you select one of these things at random, it tells you the chance it'll fall in that range, or tells you the percentage of all of them that fall in that range. And if you think a whole lot about this, you might be like, oh yeah, it makes sense that it means either of those two things. They're kind of saying the same thing in different words. But you're not trying to think deep about this because you're just trying to get what you need to pass a stats class. So maybe I'll leave that there. I didn't write out these interpretations, but hopefully you can get them from here. If I randomly select a dog, there's a 7% chance that it barks louder than 95 decibels. In other words, 7% of all dogs bark louder than 95 decibels. That's all we're getting at here. To recap this video before I quit it, the absolute minimum you need to know for this section. 1, this normal distribution shape. The reason I drew this curve to look like this, it's the shape you're always going to do, so get used to drawing that shape. It's this symmetric bell-shaped curve. Second thing, every single problem will tell you the shape is normal. That's the only shape we're studying. And it'll give you mu and sigma, the population mean. Be very nice if you knew this. Population mean is always given by this weird looking symbol mu, and the population standard deviation. It's always given by this little symbol sigma. Every problem has to give you those three things. That draws this shape, put the mean in the middle, count up and down by the standard deviation. That's what 3 is saying here. Always sketch the curve, put the mean in the middle, count up and down by the standard deviation. And then fourth, this is boldface because this is the one thing that students tend to not get out of this section that they really end up needing for future sections, is how to interpret if an area is shaded. The area below the curve in a given range can represent two different things. The probability that one dog can bark this loud, offensive tackle weighs this much, whatever. Or the percentage of all dogs that bark that loud. Following that, that's everything you need. Sorry for making this first video a little bit long. I'll try to make future ones a little bit shorter.